I have this container which you can put your business card or your name on a note, and you could be selected to win full access pass to the OpenStack East Summit that's in August. So it's only one ticket and you have to be here to win. And if you do win, the OpenStack East committee will send you an email with the code. I don't have it. So we'll start in about 1 minute. I will put this container on the Ubuntu table. By the way, there's a swag table there from Ubuntu Canonical, so help yourselves to what's left over from it. I won't pick the card, someone else should. And we'll do this after the first presentation, at the end, the last second. After the first presentation. And don't feel bad if you don't win, because it's only $99 up to May 23rd. So it's not a huge loss. I'm going to stand over here, blinded by the light, while I flip through these slides. So we're about to start, so have a seat. I'm sorry the laptop is here, it's a little weird. Okay, so once everyone sits down, no, okay, you don't have to sit down anymore. Okay, so welcome everyone to OpenStackDC Meetup number 31. And we've been around since December of 2017, in the early days of OpenStack. And today we have 3 sponsors: Canonical, the creator of Ubuntu; Pivotal.io, they couldn't attend today, but they did sponsor; and Sunayo, a new kid in town who will tell us what they're doing with big data. So today's presentations will be on application modeling, containers, OpenStack, Sahara, and big data. And we want to thank Canonical, Pivotal, and Sunayo. So everyone give them a hand thanking them. Thank you. So today's topics, as I covered already, we met, we greeted, and we are eating. So we're about to start in a few minutes. So Arturo Suarez will present on a topic on your next career move, modeling. They're taking resumes. Okay. And Brendan James on big data using OpenStack Sahara. And myself and Han, who couldn't come today, are the organizers. And next meetup, we don't have one on the schedule. So if you want to sponsor or present, we can start the ball rolling. And remember, OpenStack's birthday is always in July. So we always celebrate it with OpenStack Foundation's sponsorship. And other corporations sponsor also. And we go to a nice venue and have a good time. So OpenStack Day East in New York City, which is, there's a mini summit that always happens throughout the world, and not the major summit. Different regions of the world have their own OpenStack summits. And New York City on the East Coast is having its first, and DC may get its own in a couple of years associated with the OpenStack East. So this is on August 23rd, August 24th, and the tickets are, for the early bird registration, are only $99. 2 days in Manhattan can be a lot of fun. So regular registration starts the 24th, and that's $299. Still not bad for a conference in a major city. So without further ado, let me introduce you to Arturo Suarez from Canonical, who will present your next career move modeling. So please, if you have questions, do go to the microphones over here, right over there, and over there, because we are videotaping, so we want to make sure that all questions and answers are captured. So, and be cognizant of the time. I'll give you 5. Let me put that over. Sure. I'll try to follow your 5, and add another 5 probably. Okay. Hi, Sam. We might need some HDMI. Oh, sorry.
also talk into the mic.
Sure, yes.
Make sure everything.
Just warming up.
Excellent.
There we go. All right, thank you all for coming. I'm gonna start, yes, modeling your next career move. Hope you're not thinking about the model you might be thinking of, but probably I will explain what it's all that about. A little bit of, about my company. Canonical is the company behind Ubuntu. Try not to, well, we've been struggling to make that. You probably, the most recognizable brand is Ubuntu. When you hear Canonical, is basically how we charge you, we send you our invoices. We have about 700 people across many different countries. 75% of us work remotely, and we have offices headquartered in London, offices in Lexington, Massachusetts, a little bit north from here, and then in Asia Pacific, Beijing, Tokyo, Taiwan. Yes, we're hiring. So if you guys are interested in a job in modeling or OpenStack or Juju or engineering of any sort, DevOps, please reach out to the guys with the orange pin here. We'll be happy to take your CVs and do an interview on the spot. Right? If you don't want to talk to us, you can still apply for a job over there in that website. A little bit about me. Arturo and OpenStack. So back in the day, 2010, I created the first distribution of OpenStack. I founded a company on the other side of the pond in Europe, created the first distribution of OpenStack. For those who think OpenStack is not ready for production, you should have checked that distribution in Bexar version. That was tough to sell, right? Now it's easy. Everything goes way, way better, way easier than that. 11, this is the number of OpenStack Design Summits I've been attending. It's the last 11, actually. I don't miss it. They're going to name one of the rooms with my name in the next one in Barcelona, my hometown. 30 plus. This is the 31st city I visit. I'm very grateful to be here. 31st city I come to talk about OpenStack. Across the board, what I get when I talk about OpenStack to different people, whatever they are, they might be in Brazil, they might be somewhere else in the world, Taiwan, you name it, they all agree on the fact that OpenStack is hard. But is it really hard? I'm going to show you just very briefly. By the way, I like to make these presentations very interactive, so please do interrupt me. The best question is going to get the last of the hats we brought. Well, I'll decide which question is good or bad, so we have to deal with that. Talking about OpenStack, this is everybody familiar with Juju? What Juju is? Juju is a modeling tool, is the core of Ubuntu and Canonical, is basically what we do and how we do OpenStack. This is a view of OpenStack. In Juju. It's a very nice graphical user interface. I believe there are 19 services out there. So if you think that's hard, or that is difficult, let's have a look at a more complex model of a service. This is a car sharing, very 4 letters, big U, you name it. They're running 40 plus services in over 54 machines, right? So what are we looking at here? Let me put that back to presentation there. So what are we looking back here? Maybe OpenStack, we make it hard, or it's perceived as being hard because we're not using the right tools to approach OpenStack, right? And this is why we're here. That's why I'm going to talk about a new phase in managing software, managing complex software, right? Back in the day, software was scaling vertically. It was a very well known stack that worked perfectly in a defined hardware. It would work perfectly across versions that would rarely appear every couple of years, and it would include very well-defined upgrades, right? That's back in the day. What do we have now? We have complex services that need to talk to other complex services in a specific way. And it doesn't even have to be a service that's part of the same suite, right? It can be a service that is built by someone else, and a service that is built in a different place, with a different language, in a different substrate, right? We have this hybrid model, this hybridization of the software. So you can have different pieces of software, different services within an application running across a cluster of many different substrates, right? So you can have containers, and you can have bare metal, and you can have OpenStack clouds, and you can have public clouds, and a service will run across all those substrates and it needs to be in an integrated way. Back in the day, you will just pay a lot of money to integrate one of these monolithic silos to the other monolithic silos, and you will get a consultant for a couple of years, and you will make that work, right? It was not as agile, it was not evolving as fast as the software today is evolving. So this is the age of big software. Big, not as in big, big as in expanded, big as in many different places, right? And OpenStack is big software. And you might think it's complex, but it's mainly because we're trying to make OpenStack the way we used to make SAP. And that is just not going to work, right? What other complex software is there? What other big software is there? Well, those are more complex or less complex than OpenStack. You're probably hearing a lot about containers, like Mesos and Docker, the Kubernetes orchestrator. But there's also deep learning and machine learning, like TensorFlow, and even, it's a pity that our friends from Pivotal didn't join us today, but they could probably agree with me that Cloud Foundry is a piece of software just as complex as OpenStack, but not necessarily difficult to tackle, right? So this new era, this big software to solve complex problems in a different way, present different challenges. And I'm going to talk about three specific challenges. The first one is provisioning hardware. Back in the day, how we provision hardware, basically someone went down to the data center and he had a bunch of servers and would carry a USB stick or a CD or something, and then he will just plug it into one of those servers, and then he will go to the next server and plug it into that server, right? But today, you're not able to do that very same process across multiple data centers in hundreds of servers. Some of them might be virtual, some of them might be physical, some of them might be of a specific brand, specific model, or specific characteristics, right? So that just doesn't scale. How do we solve that in Canonical? Again, this is a tool we developed internally, and it's offered, it's open source, you can just use it. It's called MAAS. MAAS stands for Metal as a Service. And it's basically a physical server provisioning tool that will allow you to allocate workloads dynamically in a cluster. And for cluster, you can understand that it's not only in one region, it might be in many different places, a cluster of servers, right? It will help you allocate IP addresses, manage IP addresses. It has a RESTful API, and it will allow you to commission any image, not only Ubuntu, but also Windows, or Linux, all that kind of Linux, like CentOS, etc. Right? How does it work? It works with PXE booting in on any protocol. Basically, we take most of those protocols and make it easy for you. That complexity on the hardware accessibility, we take it into the tool, and you can just operate it regardless of what protocol comes next. We will take care of that. It will help you have an inventory of your components. We'll have you commission, do all the testing, dynamically allocate those servers to specific workloads, and also decommission and reallocate later, right? So if you're looking at doing a short proof of concept for a specific workload, you can commission those servers for that workload and then decommission them and get them working on something else, right? So I have like 50 more slides around MAAS, but this is Canonical. We have this tradition of making live demos. Most of them work. So I have invited Omar Lara all the way from Mexico City to help me show you how MAAS looks like. Omar.
Thanks a lot, Arturo. Hi everyone, I'm Omar. I want to show you a general interface of Metal as a Service, how does it look like. And essentially here, what we have, it's Metal as a Service 1.9. Let me refresh this. I'm connected to my VPN. So this environment that you are looking at here, it's composed of 10 nodes, 10 physical nodes. We have a tool that we call an orange box. I don't know if you're familiar with this orange box, but essentially it's a set of NUCs that are inside a huge case, a huge shell. And here we have 10 NUCs by Intel, so I'm going to expand this. And as Arturo has mentioned, the life cycle to provision this physical node and to treat them as a cloud essentially is what MAAS does. So for example, once you already have registered these servers, means that we can control the power cycle life management, right? So for example, here the different protocols that Arturo has mentioned is referring to different methods or protocols like IPMI, AMT, UCS, from Cisco, HP Moonshot, etc., that you can control or to talk with these different APIs just to power on and power off those servers. Because essentially it's a Pixie boot server where we just expose these minimal Ubuntu images that allow us to commission all the devices that every server has inside. So once you can control all these different mechanisms just to power on and power off the servers, the next process that you'll see is the commissioning process. So for example, let's say, okay, I need to recommission the node 02, so I just commission that node. Now it's ready, but I'm going to recommission that server. And essentially the process, what it's doing is just to boot from network, from IPv4 network. You can boot from IPv6 network as well, because we support those kind of features. And once you, this server is grabbing the image to boot from that Pixie server, we just insert into a database, a Postgres database, the different devices that are listed inside that server. So we can be aware of what kind of hard disk drives do we have, how many processors, how much RAM memory do we have, how many network interfaces, etc. So once it's commissioned, for example, I'm going to click on the node 03, you'll see this information already filled here. So for example, I have on this node two interfaces, ETS0 and 1. I can tie or attach them to a specific fabric that essentially is a kind of networking zone where I can work on with different subnets already set. I can manage the different, if I have a trunk port, I can manage the tags of these VLANs used to configure or to provision this operating system with a specific VLAN tag on that interface as well. And of course, we are exposing a DHCP server inside the MAAS server just to guarantee that all these servers, when they are booting, they can pick a specific IP address. So we have all the IPAM, IPAM management process for all these different IP addresses and subnets as well. So you can see here storage as well, SDB, SDC, for example, how many gigs do we have there. you can tag all those different components in the case that when you want to install any workload, you can use those constraints or those tags to specify, okay, I need to provision a server with at least 24 gigs RAM that is in the rack 100 with the VLAN tag 201 with at least 16 gigs RAM, etc., etc. So these different mechanisms or constraints that we already have set on top of those nodes, just to tag them, are on this section. So you can list them with any keyword you want them to identify them. So here I just want to prove, for example, here the node 0 train. Let's deploy an operating system. So essentially, this mechanism, it's a mechanism to do a zero-touch deployment of any operating system. So I can deploy any Ubuntu server, any CentOS server. We support CentOS, we support Ubuntu, we support Windows 2012. I mean, as supported, but essentially you can upload your custom image and you can provision that any image on top of that server. So here I'm going to deploy an Ubuntu 16.04, and then I will just transfer the microphone to Arturo. And maybe when we get back to do a demo, now we are deploying, I can show you how Ubuntu was provisioned.
Okay. So I told you I had a few slides there. We can just jump to the next challenge. So once we have deployed or provisioned our hardware, we still need to deploy the software. And again, remember this is a complex software. OpenStack is too big for an app to get, right? For the hack, how many projects do we have currently in OpenStack? Hassan, you know that one. You can't tell, you haven't really had. All right, so it's 54. So it's 54 moving pieces. Not all of them are, you know, what you call the core OpenStack. There's only a bunch of them that are really proven, but you have two speeds of OpenStack. One of them is the core OpenStack, which is fully resilient, fully tested, fully reliable. Everyone is using that. And then this thing called the Big Ten, where everything can fit into that. Right? You could start an OpenStack project tomorrow and get yourself a nice job or something, right? In an OpenStack community. It is very complex to do an apt-get install. So what is our solution to all these different moving pieces that each of them might evolve? In the case of OpenStack, they have pretty much the same cadence. It was not like that a few years ago when Swift was Swift and they would release whatever they wanted, and the rest of OpenStack was the OpenStack that was released every 6 months, right? But imagine you have some pieces of your monitoring system that releases every 2 years, and some pieces of your, I don't know, HA proxy that will release every month or every week. Right? What do you do to keep up with all those moving pieces and make still your integration of all those little services we showed in the mobile? You make those integrated nicely, neatly, in a reliable way. Right? Our solution to that is you need to reuse those components. You cannot be taking care of all those components yourself. You need to reuse and relay on the work some other peers are doing. So the guys doing OpenStack will do that. The guys doing the RabbitMQ will take care of the RabbitMQ. Guys doing the database will take care of the database, and it all needs to talk nicely together. That reusability, because of the different nature of each of those services, will require some level of encapsulation, just to make sure there's a common ground for all those services to talk to each other in an understandable way. And that encapsulation is basically what we are trying to draft in our models, right? That encapsulation is basically a ground where services can talk and relate to other services. We have like Nova talking to, well, everyone talks to Keystone, I guess. Horizon and Cinder, there would be the RabbitMQ and the NTP and the MySQL and the other databases as well in that model. Again, we showed that model of OpenStack already. Let me just give you a little bit of detail on how this is done with Juju. Juju is our modeling tool, and each of the services are declared in what we call a charm. A charm is basically a configuration of that service that will not only tell you how that service is deployed, but it will tell you also how that service talks to other services and which services can he talk to, right? That's done by declaring interfaces. So we have a MySQL and a RabbitMQ, and there's an interface that provides the database, and there's another interface in your RabbitMQ that consumes the database, right? So once that relationship is defined in the charm, we're going to be able to create a relation between those two services, right? So a service offering a database and a service consuming the database can talk to each other. Does that necessarily need to be a MySQL database? Well, it depends on the configuration of the charm. You might be showing that RabbitMQ talking to any other database that is already charmed. So you get to choose which database that RabbitMQ that guy talks to, right? But you know that he needs a database to be functional. All right, that's as I said, the MySQL relationship. So the model simply describes complex topologies, right? What talks to what can talk to what. It's just a combination of the different services out there, right? So when you get a monitoring system, it will be a monitoring system talking to some web service that will be specified that it consumes it, right? You can make the analogy to the OpenStack world, right? Then we go to the third challenge, right? It has nothing to do with just with the deployment, and this is included also in our modeling systems, right? It has to do with the operation. Again, deploying an OpenStack is something we've seen. There was a numbers contest a few years ago. You can deploy in 30 minutes or in 15 minutes or in 10 minutes. It doesn't matter. The trick here, I'm going to just throw another question, right? How many of you guys have upgraded an OpenStack cloud successfully? How many? Right? So that is the challenge, the operation of that, the backups of that, the scaling out of that, right? You need to keep that cloud up and running, hopefully, in your data center in the next few years, 10 years, say. Whether you deploy that cloud in 10 minutes or 20 minutes, it is not relevant anymore. So I'm going to let Omar talk you through the operations.
Thank you, Arturo. Actually, this operational model, or let's say methodology to try to manage all your big software is encapsulated in the magic behind the charm. I mean, the charm is the magic behind Juju. But the magic behind the charm is what we call the hooks. So these hooks, essentially think of this Juju server as a kind of event server that essentially is just in a fork status, just listening to when to trigger specific events, right? So the handling of these different events are managed thanks to the hooks. So these hooks directory that is actually inside the charm, this piece of software that is encapsulating this kind of operations, it's where it's a state, okay, what steps I need to follow to build specific software or to install the software, or where do I have to retrieve the packages or to download them, to install them, and then to build them, or to upgrade, or to check health, or etc., etc. So these different hooks essentially are these events that are triggered once whether a relation is detected. I mean that this charm is related to another charm, because essentially Juju does what is told. So to do that, the hooks is the concept or the key term behind the chumps. And these different hooks, for example here, you can see the dash relation something, join and leave, are those events that are triggered once the relations are detected, right? So at the same time, you can say, okay, I need to scale out my solution. So for example, here you have a service that is a MySQL. You always are thinking of services when you are using Juju. You are not thinking of machines or virtual machines or infrastructure, right? Or servers, but services. So let's say, okay, I need to scale out my MySQL because maybe I have a strategy inside the hooks and inside the chunk that is saying how to scale and how I'm going to relate with the rest of the services when I scale. So for example, this is a RabbitMQ that essentially has a relation between these different MySQL units, what we call a unit, that essentially is, they are acting as a peers, right? So we have their peers of MySQL, and when we just scale them out, thanks to the Juju capabilities, we need to take care, or Juju needs to take care as well of all the relations that are connected between them, right? So for example here, we just scale them, and all these peers essentially needs to talk with the rest of the services. So let's say, okay, these different units of RabbitMQ require a new physical server or a new virtual machine. We need to spin up a new instance from Juju because Juju is configured to talk directly with the APIs of any cloud provider. So we need to spin up these virtual machines, and then we need to take care of all the rest of the process in terms of of tying the relations. So here again, you'll see that this component that is the RabbitMQ server essentially is with all this complexity in terms of how to operate with the rest of the components in an OpenStack model. You can see that Juju takes care of all this process, right? So, and the main idea of this, how can we create this interoperability, is behind the general idea of how to do open source. I mean, the key concept or the key component to do that is essentially the collaborative component, right? I mean, the crowdsourcing term. So when you are crowdsourcing these operations from raw materials, let's say, okay, I have these different recipes of Puppet, these different recipes of Chef, or these playbooks, or these, you know, different minions from SaltStack or Bash scripts or whatever, tarballs, zip files, jars, different libraries, Ruby gems, Golang, Docker images, KVM images, Hyper-V images, whatever different component that usually as a DevOps or as a sysadmin you need to deal with, essentially you do this, or you apply this key component that is the crowdsourcing, and eventually you try to combine those operations. So what we are doing, or what Juju is doing, is essentially encapsulate those operations, right? So encapsulating those operations are thanks to this way to understand how to interact or to interoperate with the rest of the components. An additional benefit or feature that you will find with Juju is that you can encapsulate actions as well. And that means that, okay, I need to operate my software in terms of doing traditional backup operations or actions, traditional, you know, benchmarking operations. I need to reset logs, I need to optimize or fine-tune or hard-code specific operations. So all these different actions can be set or can be can be graded inside the charm, and let Juju or your Juju admin just to operate with the rest of the pieces of software that you are relating with. So this is the same situation, right? This MySQL service with this RabbitMQ service can have different actions already encoded, so you can just trigger them whenever you want. So as I have mentioned, charms are encapsulating those operations. So the process to install, to configure, to connect, to upgrade, to in in a successful way, that it's very important, to take control of all the steps that we need to perform step by step with no breaking the rest of the components are done thanks to the magic that is behind the hooks, right? So just to finalize, I can show you here. Let me show you in my laptop. If you go to the jujucharms.com website, that is where we have our charm store, there you can always select any charm that you want. Let's say, okay, I need to, actually I have here, yes, I have a full operational Juju GUI environment. So here I have a charm that is the Juju GUI charm. Actually, this interface is already charmed, right? And I can add any service there. So let's, I don't know, for example, let's add a WordPress there. And I want to show you how all these hooks are already written inside the charm. You can write your charm on any programming language, right? If you are using Python, you'll get more benefits because you can speed up the process to write the charm, because we have already created a library called charm helpers that essentially is a good abstraction way just to isolate the different operations like installing, like upgrading, like relating with another charm, etc. But if you don't want to write your charm in Python, you can use any other operating system. So I'm modeling here a traditional, MySQL with WordPress service, and I'm just going to relate them. Then I will commit the change. And once I commit this change, what is happening here, this Juju instance is running on top of Amazon Web Services. So my Juju controller server, the Juju server itself, is spinning up some instances from Amazon Web Services because Juju has all the ability to talk the API from AWS, right? So once we get those machines, the Juju agent will install will follow the steps that are inside the charm. So if we see the charm, okay, let's see. Okay, what's going on right now with MySQL? Okay, it's pending, but let's click on the charm here, and you'll see here that we have all the files that essentially describe what the charm does. So the most important file is the metadata.yaml file. You can see here that you need to define the name of the charm, the summary, the description. If you want to apply some tags just to catalog or manage this piece of software inside the charm store, it's very useful to do it. What kind of relations you can require from a different charm, and what kind of relations you want to provide, right? So this charm that is a WordPress requires a database. That's the reason I have related with the MySQL. That interface is what we call a MySQL. You can require maybe an NFS mount point or maybe a cache server like Memcache, for example. And what does WordPress provide? Well, it provides an interface that essentially is just an HTTP web server. And you can set this charm as a peer charm. That means that, okay, we need to do an active architecture with WordPress, so I'm going to act as a peer. And that means that inside the charm, you program will develop when to act as a leader. So there's a leader election, and it says, okay, this WordPress, it's going to act as a leader. So here you define all these different definitions inside your charm. And here, as I have mentioned, you have the hooks file. So if I just click on the install hook, for example, what you will see here is a bash script, right? So there are different operations that are running step by step once the Juju deploy or the commit change is applied on top of our Juju GUI, right? So first, here, for example, is the repository is set. Then we update and then upgrade. We install different packages we require to install this WordPress. We see we have NFS module. We log all these operations in our Juju engine. We do some change mode, make yours, etc. So these different operations that you can see are already encapsulated in that charm, right? So when you are writing your own charm, essentially you are putting those steps inside this script that essentially are just these instructions to perform those tasks, right? So this is another way to see how the hooks are related. And if I want to say, okay, what happens when I relate a MySQL, for example? So when that happens, this script, that is the DB relation change, start to act, and there are some common variables that are set there. We require from the charm, MySQL charm, a database name, a username, a password name, a host name, a private address, etc. So all these operations, of course, are already charmed as well, or installed, or already written into the MySQL charm. So it acts as the same way. Okay, I'm going to press the microphone.
Sure. So just a few takeaways from this conversation. You guys, we're going to be around here, so if you have any questions on that, please find us, and we'll be happy to answer them. Right? So we're in the age of big software. There's a phase change that requires a new approach. If you try to approach big software the way we used to approach old software, whatever that's called, we will either fail or make ourselves like very expensive practice, or both. Right? OpenStack is big software, right? And it does present, as the rest of the big software, those challenges around how to provision the hardware in an efficient way, how to deploy the software in an efficient way, that complex software, and how to operate. This is the main element of the new way of doing things. You can deal with provisioning software or hardware, because you might do that not too often, right? But you operate every day your software, right? And then modeling, this thing we saw, reusing components, reusing code from third parties, reusing different languages, different ways of doing things, making sure those can talk to each other. That crowdsourcing approach Omar was mentioning, that is the most effective way to approach this big software challenge. Right? And I want to thank you all for patiently attending our presentation. As I said, we're going to be around. Hope you enjoyed it. Thanks for having us here. Thank you.
Do you have any questions there, Mike? Any questions? There's a question.
Is it possible to track the evolution of that model as it, you deploy one thing, then you kind of make a change? Are the changes
Yes.
tracked and so on?
Yes, so Juju, each of the services, when you compound different services, is what we call a bundle. Each of the services allows versioning. Each of the bundles, that composition of different services and the relationship between those, include versioning as well. So you can define how, this is a collaborative tool. Imagine in that canvas we're looking at here, you're working on your MySQL charm and your buddy's working on the WordPress charm, right? You can make sure those talk together. Your version 1.1 will talk to his version 2.1.1, right? And you create a bundle out of that, those two versions, and you version that 1.0, right? So you can manage all that and make sure you can track all those changes as well.
And does this modeling also tap the mass? In essence, bringing machines up?
Sure. So this is how it works. Juju works on top of what we call providers. Mass will be a provider to Juju, the same way as Amazon will be another provider to Juju. OpenStack will be another provider to Juju. Google Compute, Microsoft, Azure, VMware, pretty much any substrate, right? That complexity we was talking about in my slide, it can be anywhere, is what Juju abstracts you from, right? So you just identify, there's a file there, there's the providers, and you identify your credentials to each of the providers you declare in that file, and you can mix and match there and have those running in different substrates. Yeah.
Thank you.
All right, thanks.
Thank you.
Let's take a 5-minute break. And then if you arrived after I stated this I made the statement, please put your name in that plastic container there if you want to be a candidate for winning a free ticket to the OpenStack East Conference in New York City in August. We'll have the drawing in 5 minutes, and then Mr. Brendan James from Sahara will present on Sahara right there. Okay, everyone, have a seat, please. We're about to start. We'll wait. 1 minute. Then we'll do a raffle. Who wants to hold? Select, rather. What was that? Good idea, thank you. Hey, Brendan? Brendan? You want to select? Yeah. Shake it up. Okay, well, let's start. So Mr. Brendan Jones from Sahara is going to pick the winning raffle ticket to the OpenStack East. Okay, 1, 2, 3. You have to be here today. Let's do it. Mark Borstein. Did I pronounce it Germanically correctly? Congratulations. All right, check.
All right. So, how's everybody doing? Everybody's good? Awesome. My name is Brandon James, and I am the CEO and founding member of Sahara. And today we're going to talk about big data and Sahara. And I'll tell you a little bit about Sahara. My clicker is not going to work for this. Hold on 1 second. Okay, so Sahara, we are a DevOps, big data analytics startup company. We primarily serve the federal space, but we do have clients in the private sector. So we're going to talk a little bit about the importance of big data. By show of hands here, how many people know or have heard about big data? Well, how many people are tired of hearing about big data? All right, I think that's kind of a growing trend. So my goal here today is to kind of provide you some insight into big data and its importance in the OpenStack ecosystem. So for those of you who are not familiar with big data or have heard big data used in many different contexts, I'm kind of going to just go back to 101 elementary school on what big data is. So big data is trying to solve a very complex problem. Today, companies and governments are required to keep track of more and more data than ever before. There are thousands of applications that are now running out there, sensors, you name it. Every device these days seems to be connected to the internet. And all that information is coming back and being captured and logged in some way, shape, or form. And now companies are trying to make sense of all that data. And this is where the tenets of big data come into play. The challenge of big data is now that you have all this information is coming in petabytes, terabytes, and even in some cases exabytes worth of data, is trying to make sense of all this information that's coming in. It's really, really difficult. And another thing that's facing companies and governments today is trying to be able to figure out, how do I deploy applications that are going to make use of these really complex solutions that are going to try to tackle the big data problems. And these cause issues from a financial perspective, on the infrastructure side, as well as a support perspective. So these applications are big, they're complex, they require very niche skill sets to be able to maintain and keep running. So yeah, are you confused yet? I can tell you MacGyver's confused, and as a system engineer, when I was tasked with first trying to solve and implement big data in my organization, I was extremely confused. For those of you who are not 80s buffs like myself, MacGyver pretty much could solve any problem with bubblegum. And big data is essentially trying to do that. It is trying to step into a space where there's very complex problems and make sense of it with very limited resources and limited tools. So along comes two big players in the big data space, Hadoop and Apache Spark. How many people are familiar with Hadoop and Apache Spark? Awesome, good, good, good. So I'm not talking to strangers here. So just to kind of give some overview, Hadoop is made up of two core components. We have HDFS, which is the Hadoop distributed file system. When you think about distributed file systems such as GlusterFS, for those of you who are a little bit more old school, who have dealt with distributed FTP, they kind of behave in very similar ways, where you're trying to distribute disk-based commodity hard drives to aggregate to a large pool of data that you can process over. The next component is called MapReduce. So MapReduce is a programming model which is associated with the processing and generation of large data sets using a parallel and distributed algorithm on a cluster of systems. Whoa, what does that mean? So basically, this application, or this programming language per se, depending on who you're talking to, how it can be used, is basically designed to be able to carve up all of the data that you bring into HDFS and be able to try to make sense of it. MapReduce was inspired by a Google white paper. I would advise, if you're not familiar with big data, that you take a look at this white paper. I will make sure that all the slides are available later on for your consumption. This white paper is excellent for bringing you up to speed on kind of where some of these ideas came from on Google's front. The next application we're going to talk about is Apache Spark. Now, if you're current in big data, Apache Spark is really what we want to be talking about today. Apache Spark is also another open source cluster computing framework that was developed by the University of California, Berkeley. Spark's implementation and sole purpose is to reduce the complexity from installation or standalone deployments and cluster deployments, and be able to allow data scientists, or even folks that don't have much experience with big data at all, to be able to quickly analyze their data and make sense of it. The one thing I'd like to make sure that everyone takes away from this talk today is that Spark is the hotness, right? If you are dealing with big data right now, Spark is kind of where you want to be at. From a comparison perspective between Spark and MapReduce, because Spark is memory-based and it's thus not file-based, it's much, much, much faster. And it just basically blows the doors off of MapReduce. Now, for a lot of our clients and a lot of big data solutions that are out there in the wild now, MapReduce is still relevant. It's still used. So, don't think that MapReduce or Yarn is going away tomorrow. They're not. But if you're new to big data and this is something that you're interested in, I would highly advise you to spend your time with Apache Spark. So, I was this little confused system engineer. And as a little confused system engineer, I was tasked with trying to figure out, okay, how am I going to get Hadoop or Apache Spark installed in our environment? And this is from a beginner standpoint. How many of you have tried to install Hadoop from source? All right, from a distribution. So if you've ever installed Apache from source or a manual installation, it is painful, really, really painful. Any Java applications, if you're familiar with Jira, et cetera, we're talking tons of configuration files all over the file system that need to be configured correctly. There's a lot of overhead from a hardware perspective that need to be implemented before you can actually make sense and be able to use the application itself. You had to spend a lot of overhead time in preparing your bare metal systems, so services such as NTP, time sync between the nodes is critical. So basically there's a lot of ramp up time before you can get to the point where you can even actually starting up HDFS or MapReduce. From a business standpoint, one of the challenges that I faced was trying to convince your leadership to take a risk of using these new tools, right? Oftentimes, when you start proposing what are the real internal resources that are going to be needed to deploy a big data solution, it can be very, very difficult to convince leadership to spend that money on the infrastructure and hardware that you're going to need to be able to do that. The other problem is if you are put in a position where you have multiple sources of data and your data sets don't really align up with each other, and you're going to need multiple instances of Hadoop or Apache Spark. It gets really, really time consuming and even more complex to deploy. So through my search, I pretty much got really frustrated because as you see today, and pretty much in all open source platforms, there is commercial support now to help reduce the burden. And as an open source purist, I was thinking, oh man, really, more product branding? But actually that product branding is quite important. So along came Cloudera CDH and Hortonworks HTTP. So Cloudera is an enterprise distribution of Hadoop. Hortonworks HTTP is also an enterprise distribution of Hadoop. Their primary goals is to reduce the burden on system engineers, administrators, as well as developers that would like to utilize Hadoop, HDFS, and MapReduce. Each of these enterprise solutions are great tools, but they don't solve one problem. They don't make it easy to virtualize these things. If you want to run this in a virtualized environment, or be able to utilize existing virtual environments, there's not really an easy way to go about doing it. It's important to note that Cloudera is an open source Apache Hadoop distribution, which focuses on providing HDFS and MapReduce solutions for the enterprise. Likewise for HTTP. For those of you who dabble in Microsoft's Azure platform, Hortonworks has a very large stake in that platform, and they have a large amount of support if you want to use it in Azure cloud platform. So this system engineer spends all this time and he's searching for solutions. I hunted high and low. How am I going to get this virtualization, utilization out of my big data application? And hey, I'm a fan of OpenStack. My current customer is using OpenStack. Somebody has to have been working on this or thought about this in the OpenStack ecosystem. Well, lo and behold, I discovered in the jungle the Sahara project. The OpenStack Sahara project is a framework that utilizes Heat, Horizon, Glance, Swift, Keystone, Nova, and Cinder to simplify the deployment and configuration of big data applications. The current big data applications that Sahara supports is Apache Hadoop, Cloudera Hadoop, Apache Storm, which was in the early days Twitter Storm, and Hortonworks Hadoop, and Apache Spark. So we're going to talk a little bit about the architecture of Sahara. This slide can be a little confusing, but it was the best available slide on exactly how Sahara works. So I'm going to spend a little time here and kind of walk over here, hopefully not triple this, and explain what's exactly going on here in this diagram. So I'll start from the visualization perspective. Here in Horizon, you have the Sahara dashboard, which we will see. And you also have a Sahara Python client if you want to interface from the command line. All of your user and tenant authentication will happen through Keystone. And then there are internal REST APIs that check against the authentication in Keystone or Horizon to see which users or which tenants have access to a certain pool of resources. Those resources are then allocated within the data access layer, and then they are worked out through, depending on if you're using Hortonworks, your EDP API, which then talks to your external data sources. You have internal HDFS, Swift, Manila, Trove, etc. And then on the internal side, you also have this provisioning engine, as well as the vendor plugins that kind of sit in between that layer. So for example, for Cloudera, Cloudera has a utility, an API called Cloudera Manager. For those of you who have probably installed the distribution, you've used Cloudera Manager. And Cloudera Manager also has an API interface that Sahara leverages to help provision your Cloudera, the new CDH instances. From there, all of this information is collected and then passed over to the heat orchestration layer. And at the heat orchestration layer, that is where your templating is done for all of the resources about exactly what system, the size of the instance, the flavor, etc., what its role is, all of those variables that can drive you insane from a manual perspective in deploying it, all managed in this orchestration suite, which then get passed off to your OpenStack Nova instances where you're actually running your instances. So, as a lost little engineer, my experience traveling the jungles of Sahara was that I came out of it with some good pros and cons. So the pros that I discovered in using Sahara is that, one, it drastically reduces the time to deploy all of those big data applications that we discussed. In many cases, some of these applications would take me hours to deploy if I didn't have my own DevOps utility to do it. And there was virtually no way to do it in a virtual environment. It reduces the complexity in the virtual environment. And then it also allows developers, individuals who just want to be able to quickly write a MapReduce job or quickly write a Spark job, a structured way to be able to do that. You can provide the developer resources that they can quickly implement their code and be able to test it against the cluster. From a financial standpoint, boy oh boy, is Sahara cost effective. If you want to be able to stand up a big data application, you can leverage your already existing hybrid cloud infrastructure in OpenStack and be able to deploy and test and slowly scale elastically your environments that you're going to be using for these big data applications. Now, along with the pros, there were absolutely some cons in using Sahara. The configuration and deployment of Sahara within your OpenStack environment, we all know OpenStack is hard, we talked about that. It has a really high learning curve. But if you can get past that learning curve, there's a lot of gold on the other side. The customization of images and configuration of Hadoop can be cumbersome in Horizon. So when you deploy your instances in Sahara, there are images that need to be built, that need to be uploaded into Glance before you can launch your respective application if you're using Apache Spark, Cloudera, etc. Those images, the great folks at Marantis have a URL where you can just download those images. But if you need to do some custom changes, or you want the latest version of the most recent version of either Cloudera or any of the big data applications we talked about, you'll need to roll your own. And that process can be a little bit complicated. Errors. So as you'll see, as we move through, trying to diagnose errors in Sahara can be very difficult. When things go wrong in Horizon, typically Horizon will spit out an error that tells you one thing, and then you actually go in the log files and you realize that was completely unrelated. And if you are a developer that's looking for the most bleeding edge versions of these big data applications, the Sahara project is typically going to be a few revisions behind. In many cases today, now with the support, the increased support that the project now has, they're not very far behind and they're catching up quickly. So for example, the deployment that we're going to do today, they're utilizing 2.71 of vanilla Hadoop, whereas the current stable now is 2.72. So they're not very far behind, and 2.72, my understanding is in the works. So yeah, it's that time. It's demo time. We're doing it live, guys. So you know how the demo guides go, so we don't really know how it's going to pan out, but we're going to hope for the best. I'm going to ask Eunice if she can just kind of hold the mic here. Okay, so here we have the Horizon login. I'm just going to go ahead and authenticate here as an administrative user. One of the things I'll let you know for those of you who have interest in trying out the Sahara project, this deployment here is a PAAS RDO installation. Sahara, to be able to deploy big data applications, you need to have a pretty beefy machine. I have done this in a DevStack installation on my laptop, but I would highly advise against that. I have a pretty beefy Mac, and it pretty much brought it to its knees. Sure, yeah. That good? Okay, so in just for reference, this box here is a really beefy box. It has 256 gig of RAM, 96 cores, and multiple terabytes of SSD storage. You don't need that to be able to test this out, but to really be able to scale out your big data applications, depending on the amount of data that you're ingesting into your clouds, you may need a pretty powerful machine to be able to run this, especially when you're running everything on a single node. So we're going to go to the project section here, and we're going to go under data processing. This is where the Sahara Horizon interface lives at. And we'll start from the right here. As you can see listed, we have the images that I discussed earlier loaded up into our OpenStack instance. You can see the instance that we're going to be using for the demo is the Fedora Sahara Vanilla 2.71 image. This is running Fedora 23 with the core components that are needed for a vanilla Apache Hadoop installation. You can see the appropriate tags that I've given it. Under the node template group, now for those of you who are big data gurus and have used Hadoop, this is kind of where that magic sauce is. So I'm clicking on the node group template of a worker node. And in this worker node, we can see listed here that I'm able to select the flavor that I'd like for this particular node to have. And because it's the master node, main node, it's pretty much handling a lot of the transactions that occur within the Hadoop environment. It needs to be a big, beefy node. So I gave it a large node, because this is where most of the data is being written to. And we can see the image that we have listed here. And for every instance that I deploy, I'm going to assign a floating IP so that no matter what network infrastructure I'm on, I'll be able to route in directly into the instance. And then when you click here under node processes, I can see that for the worker node, I've only allocated it the responsibility of a data node. So that's the only HDFS process that will be running on this node. And in the security tab, if you have any specific firewall restrictions that you need, you can customize them there, or you can just use the auto security groups. I tend to use auto security groups because they just work. Under the HDFS parameters, this is where a lot of people that are purists with Hadoop get a little bit leery about Sahara, and they have done a fantastic job of making sure that every configuration that you could possibly change in your data node can be completely represented here in your Horizon view. So you can see there's a whole lot of options that you can change here. Many of these you won't need to change just to be able to test this out, but if you are rolling this out in production, the heap sizes, things of nature are really, really important. So for the sake of the demo, we're going to leave this be here. Go to the bottom, so cancel. And then we'll take a look at the master node. I think earlier I might have said this was a master node, worker node was, but no, this is the master node. And we can see here that the master node has even more of an expected workload on it. So therefore, we selected a M1 extra large flavor for its deployment. And as you can see, we also have assigned a floating IP address. It is using the vanilla image. And we can see under the respective processes that this master node image will be running, we have the name node, the secondary name node for high availability failover, and resource manager for Yarn, which is the latest version of MapReduce now. And we have the MapReduce history server, job flow, Uzi, Hive processes, and the Hive server. And each one of these, as you saw on the worker node, we can take a look at the full configuration to see all the different values that you can set based on your environment for production to optimize your workload. And this is kind of digging deep into HDFS, but I wanted to make sure that I illustrated that you can, in fact, really dig deep into the configuration before you deploy. So moving on to the cluster templating. So I've already, for the sake of the demo, I've just kind of pre-populated these to kind of speed up things. We have a cluster template name of vanilla cluster, and we can see here that there is one master node and 6 worker nodes. So if I go in here and edit the template, you can see here in the node group section, I can scale the size of my HDFS environment. So if I wanted to have more than one master node, I was doing HA with some serious failover. We were doing a secure Hadoop instance where we have a Kerberos authentication token. We can make those configurations here. As far as the worker nodes are concerned, we can scale this up and down based on how much data we want to write to HDFS. If we have a huge amount of data, we can scale this out to 100 nodes, depending on the available resources that you have to your OpenStack environment. Along with further HDFS parameters and configurations. So replication, those of you who aren't familiar with replication, that basically for every block that's written to the HDFS file system, it gets replicated across, right now in the configuration, 3 nodes. So you have some redundancy if you have a system or a worker node that goes dead, you don't lose your data. So now what we're going to do here, I'm going to make sure that I am still logged into on the back end so you guys can get a good view. So I have top here running on the instance. And again, this is the PAAS installation. And then on the second tab here, I am simply tailing the log files from Sahara. One thing that I would advise you for your OpenStack deployment, those of you who are doing it, and Elasticsearch or log aggregation is your friend. These services write a tremendous amount of data to log files, and being able to visualize and see what's going on in the back end gives you greater insight to your environment. So we're going to go ahead and launch a cluster here, and we're going to name this demo 285. All right, and we're going to only deploy one cluster. We're going to associate the PKI key pair which will allow passwordless SSH into all of our nodes within our HDFS cluster. And then we're also going to make sure that the communication, the neutron management network of these services runs on the private side of our subnet. And the reason that I typically do that is I don't want that configuration traffic passing on my main network. I'd like for that traffic to remain internal. Tends to be a little bit snappier. And here, if you wanted to have other tenant members have access to this cluster once you've deployed it, you can either restrict it or make it public based on available resources. So we're going to go ahead and launch this here. And as you can see now, it's in the spawning phase. And if we kind of shoot over here, let's see if I can make this font a little bit bigger. Okay, so we can see now the heat engine is churning. We should see some a lot of processing coming from the Sahara API engine as well as Nova, and we can actually start to see out of those 7 nodes that we deployed, they are starting to spin up and do some work in the background. And they're busy beavers right now. And then, let me blow this up a little bit. So we'll start to see some output here from the Sahara API log that will should reflect in Horizon, but typically that data gets written to the log files faster than it gets updated to Horizon. So it's something that is good, handy to use. Typically, this process can range for a small deployment of this size, anywhere between roughly around 8 to 10 minutes. So hopefully the demo guys will be kind and it'll be just as quick. And we're still in the spawning phase. And I'll probably use this time while this is going. If anyone has any questions for the things that we've covered so far, I can take those questions now while this is processing in the background.
So do the images live in Glance, or are they separate from Glance, the Hadoop images?
So the Hadoop images do live in Glance. You actually build them using the Sahara Elements package, or you can download them directly from Orantis, who hosts them. But yes, they live in Glance, and upload them into Glance, and you would treat them as you do any other instance image in OpenStack. We'll just see where we're at here. Refresh this. Okay, so now we've moved from the spawning stage into the preparation stage, and at this point, this is now where the APIs are talking on the back end to Ambari for this particular installation, I believe. If it was Cloudera, it'd be talking over the Cloudera Manager API, and if it was Hortonworks HTTP, it would also be talking over Ambari. And we can see there's a little bit of information coming back here from the Swift logs in the API, and blow us a little bit more, but readable. And basically, this is just letting us know, even though it's really kind of nonsensical for most people to look at this right now, but if we encounter any type of massive failure in the provisioning of the cluster, it would start to show up quickly in the API or the engine logs. So we are now in the configuring stage. Let's take a look. Looks like we were successfully finished the configuration stage, and now we are in the startup phase. And in this process, this is when all of the data nodes the processes all involving Hadoop are being started. The name node is formatted, and this process is all happening all in the background with no user intervention. we're still kind of hovering in the starting phase. So this process take a little bit of time, but I'm open for questions or.
So you had the choice in terms of where the data was and it listed ephemeral. Do you have any sort of experience of having ephemeral on local disk versus Ceph?
So I have not used Ceph in the deployment of this yet, but it's my understanding that it pretty much treats it the same. From a performance standpoint, it would be something that I would definitely look at, like, you know, how important is data retrieval in your HDFS environment? So, you know, if you're using block storage, you know, make sure that you have, you know, a significant amount of bandwidth in between there. But in my testing, I haven't had a need to do it yet. Okay, so looks like we successfully deployed our cluster. We can see here that it did a check. We can see the status is active. And we're going to go ahead and click on this cluster here. And then from here, we can now see all the details that are associated with our HDFS environment. And we can click on status pages here. We can see that, voila, Hadoop is running. HDFS has been provisioned. Make this a little bit bigger for everybody to read. We have roughly 450 gigabytes of HDFS space. We can see that we have 6 data nodes that are all live. 0 of them have been decommissioned. If we go here, we can also take a look at our Uzi console. So we see any of our Uzi jobs. And then we can also take a look at our MapReduce jobs. So anything that's going to get processed in Yarn or MapReduce, they would show up here. Now, for the final proof in the pudding, we are going to SSH into our master node. And it's probably going to bark at me about this key, unless the IP changed. Let's see what it set the master to do. Yeah, they did before you, which is good. Okay, 1 second, let me sit this down. Okay, so we are now in the master node. Okay, so we'll do it clear here. And now what we're going to do is I have a some sample mock MapReduce job. So the first thing we're going to do is we're going to do a Terra gen, which we're going to generate random data in our HDFS cluster, write it out to HDFS. Then we're going to run a MapReduce job against it and sort it. And then from there, we're also going to run a job to validate the sorting. Something to do up there. It's kind of tough with this mic in my hand. What I'm doing now is I'm just adjusting the number of jobs here based on the user. The number of nodes that I have in the environment. Here, I just realized I skipped 1 step, so the sudo root, and then I'm going to su to the Hadoop user. So all these jobs need to run as the Hadoop user. Okay, so now now we are actually running the TerraGen. Let me just see where we're at time-wise. So as you can see right now, we're writing the data to HDFS. And then the next step now is running right now is the sorting of the data that was written to HDFS. And this workload is being distributed to all 6 nodes that we have in our Hadoop cluster. And the last thing we're going to do here is validate that the sorting that we just did on that data was actually sorted correctly. This TerraSort TerraGen is like the standard benchmark against any Hadoop distribution. So this is not something that's kind of a one-off. This is typically used as a guardian utility for any production deployment that you do with HDFS. Now we'll go take a look in the logs here, and we should see all 3 jobs that were completed successfully in a very quick time. And we have a completely healthy Hadoop, vanilla Hadoop 2.71 installation. And the last thing that I will leave you with is the beautiful thing about Sahara is the minute that you are done with this environment and you've completed running your tests, you can just select this checkbox and click, where is it at here? Delete cluster. There we go. And we can just click delete the cluster, and then boom, all those available resources are gone. They've been freed up. Or if you need additional resources or you need another cluster, you can quickly spin it up from those existing templates. That concludes the presentation. I do have one additional slide on here. I'd like to just make sure I cover here. I'd like to give a special thanks to Trevor McKay, Michael McCoon, Ethan Gerford, Chad Roberts, and of Red Hat. They are huge supporters of the OpenStack Sahara project. Morantis is also large contributors to the OpenStack projects, and there's many other contributors that I just haven't named. But these guys are absolutely fantastic. If you have any questions or you'd like to join us, we are on Freenode IRC in the channel OpenStack Sahara. Also give a big shout out to Kelsey Hightower, who helped me facilitate giving this talk today. So thank you very much. I appreciate everybody's time this evening.
Any questions?
Do you have to launch a whole new cluster if you want more nodes, or can you attach new nodes to the existing cluster?
So you can attach new nodes to an existing cluster. Yes, you can attach new nodes to an existing cluster. One of the things that I've actually requested is the ability to be able to start or essentially like pause a cluster to be able to provide some sort of migration, but that hasn't hit the roadmap yet. But yes, you can absolutely scale up your cluster infrastructure based on need.
And if there are no more questions, you would like to talk about the name of, where that name comes from, of the company?
Okay, so
Just
so it's actually interesting, the name of the company. So my partner, Ryan Yu, him and his wife came up with the name. And I don't know, Ryan, do you want to elaborate on that a little bit? No. So that answers that. No, but it was really a name that him and his wife came up with. And Ryan and I have worked together for a number of years, and it resonated with us. And we are all about integrity at Sahara, and we are huge advocates of DevOps, OpenStack, and big data.
Any more questions? Okay, thank you very much. And that concludes our meetup. And thank you, Canonical, Pivotal, and Sonayu for the tonight's sponsorship and presentations. Thank you.